graph the given function, state the domain and range, list the y-intercepts and any x-intercepts if they exist. My function is f of x equals the square root of x plus 1 minus 3. For my domain, I'm interested in which x values can go into my function. One thing I notice is that I'm going to be restricted because I cannot take the square root of a negative number. So when I state my domain, I'm interested in which x values will enable me to make sure that I have a positive right here. In other words, x plus 1 has to be greater than or equal to 0. If I subtract 1 from both sides, I get x is greater than or equal to negative 1. So my domain then will be from negative 1, and it will include negative 1, all the way to infinity. So a bracket for the negative 1 and a parentheses for my infinity. For my range, if negative 1 is the critical value and I'm looking at my function, if I put negative 1 into here, I have negative 1 plus 1, so that's 0, and I start with negative 3. So for this, I'm looking at y then. Okay, it has to be greater than or equal to negative 3. So my my range will be from negative 3 to infinity. In terms of my x-intercepts, I want to let my y usually, but in this case, my f of x equals 0. So 0 equals the square root of x plus 1 minus 3. I can add a 3 to both sides so that I have 3 equals the square root of x plus 1. And then to eliminate the square root, I can square both sides of my equation so that I have 9 equals x plus 1. Subtracting 1 from both sides then, I get 8 equals x. Since this is an x-intercept, I'll have 8, 0 as my coordinate. For my y-intercept, let the x equal 0. Or in other words, find f of 0. So in this case, it'll be 0, the square root of 0 plus 1 minus 3. 0 plus 1 would be the square root of 1 minus 3. Square root of 1 is 1 minus 3. Or simply negative 2. So my y-intercept will be at 0, negative 2. When I go to graph this, I want to create a table which I used negative 1, 0, 3, and 8 because I was thinking about which values would be perfect squares. Thinking about 0, 1, 4, and 9. The values that would make my radicand 0, 1, 4, and 9 would be negative 1, 0, 3, and 8. That's why I chose those. Putting those values in, negative 1 plus 1 minus 3 is going to equal negative 3. So I have the coordinate negative 1, negative 3. If I put 0 in, I get the square root of 0 plus 1 minus 3, which is going to be negative 2. So I have the point 0, negative 2. If I put 3 into my function, I get 3 plus 1, the square root of 3 plus 1 minus 3, and that's going to equal negative 1. So I have the coordinate 3, negative 1. And finally 8, the square root of 8 plus 1 minus 3, that's going to be 0. So I have the coordinate 8, 0. Plotting these points on my graph, negative 1, negative 3, 0, negative 2, 3, negative 1, and 8, 0, I get a sketch of my graph.